What if I told you that the biggest, most important decision you make about your new home has nothing to do with the floor plan or even where you build it? Today, we're looking at two completely different ways to build a house, and the choice between them, well, it could decide how your home handles a storm, how much you're going to pay for energy, and even how long it takes to get the keys. This is all about building for resilience.
And right away, you can just see the difference. I mean, on the left, you've got that familiar skeleton of a traditional wood frame put together piece by piece. But on the right, that's something else. Solid, pre-engineered walls going up in these huge, clean sections. We're talking two totally different philosophies here. And the journey from foundation to finished home, they're worlds apart.
This really gets to the heart of it, doesn't it? This whole explainer is about that one core question. We're not just picking materials. We're deciding on the fundamental DNA of the home, how it's going to perform, how safe it's going to be, how resilient it is. It's a choice between the way things have always been done and a precision that comes from a factory floor. So let's get into it. Let's really break down what we mean when we talk about these two ways to build, the one we all know and the one that's made in a factory.
Okay, so first up is traditional stick-built construction. It's what probably pops into your head when you think about a house being built. A frame goes up on site, one 2x4 at a time. It takes a whole parade of different crews, framers, sheathers, insulation guys, you name it. And the most important thing to get here is that how well that house performs depends entirely on the skill and coordination of the people on that specific job site on that specific day.
The alternative is something called an MgO SIP, which stands for Structurally Insulated Panel. The easiest way to picture it is as a structural sandwich. It's engineered and built in a controlled factory setting. It's got these super strong magnesium oxide skins on the outside and a solid insulated core. And here's the real game changer. That one panel does the job of the structure, the insulation, and the air barrier, all packed into a single piece.
All right, so now that we know the two contenders, let's put them to the test. The very first challenge for any building project is a race against the clock, a race against the weather, and that's all about time and risk. And wow, here is the first massive difference. We're talking about time to enclosure. That's just a fancy way of saying how long it takes to get the walls in a roof up so the inside is protected. With a panel system, you're looking at just a few weeks. With a stick-built home, it can be 3 to 6 months or even longer. That huge gap in time opens up what people in the industry call a critical risk window. And believe me, that risk window is a really big deal. Every single extra day that wood frame is sitting out in the rain and sun, you're just asking for trouble. We're talking moisture damage, mold, warped materials, not to mention weather delays that can throw your whole schedule and budget right out the window. Big industry players like FM Global point out that this long exposure time actually increases the insurance risk for the whole project.
So, building faster is a huge win for reducing risk from everyday weather. But what happens when the weather gets truly dangerous? Let's shift gears from speed to pure, raw strength and durability. The difference here is just night and day. A wood frame, well, it's made of wood. By its very nature, it's combustible. It's fuel for a fire. But the magnesium oxide skins on these SIPs, they are non-combustible. They're rated ASTM E84 Class A. That's a standard fire safety test, which basically means they just don't contribute fuel to a fire. That's a massive, massive advantage when it comes to safety. And that strength isn't just about fire. Think about the incredible twisting and pushing forces of a hurricane wind. Engineers call that racking. Well, the data from the tests is crystal clear. Stamped engineering reports show that these solid panel systems have significantly higher resistance to those forces than a standard wood frame wall. And this isn't just some marketing fluff. It's backed up by some of the toughest testing standards in the world. We're talking codes designed for Florida's high-velocity hurricane zone, literally one of the hardest places on the planet to build for wind. These systems are truly engineered for the worst-case scenario right out of the box. So why is there such a big difference in strength? Well, it all comes down to connections. A stick-built house is held together by literally thousands of individual fasteners. Nails, screws, connector plates, all put together by hand on a busy, chaotic job site. The strength of the entire building really hinges on every single one of those connections being done perfectly. Now, contrast that with a factory-made panel system. You're creating a continuous, solid, integrated wall. There are way fewer joints and connections, which means there are way fewer potential points where things can fail. You're basically taking the precision and the quality control of a factory and putting it directly on your job site. The result is a much stronger, more predictable building. Okay, so we've covered how they're built and how they stand up to a disaster. But what about just living in them, day in and day out? That brings us to our next big challenge: efficiency. Now, this number might look like alphabet soup, but stick with me because it's incredibly important. ACH 50 means air changes per hour, and it's how we measure how leaky a house is. A typical brand new stick-built house might test at a 3 or a 5, maybe even higher. These SIPS systems, they regularly test at 1.5 or even less. That means far, far fewer air leaks. But who cares about a technical number, right? What does that actually mean for you, the person living inside? What does a super airtight home actually feel like? Well, it feels like comfort, and it feels like saving money. Fewer air leaks mean your heating and cooling system isn't constantly battling the outside world, which means lower energy bills. It means no more annoying drafts or cold spots in the winter. And because these panels are inorganic, they don't rot, they don't grow mold, and termites can't eat them, it also means a healthier and more durable place to live. And here's another big reason why they're so efficient. It's a concept called thermal bridging. In a normal wall, every single wood stud acts like a little highway for heat to escape in the winter or sneak in during the summer. It breaks up the insulation. But with a SIP, you get a continuous, unbroken blanket of insulation from top to bottom. There are no bridges for your expensive energy to escape across. So let's bring it all home. When you add up the speed of construction, the built-in strength, and that incredible day-to-day efficiency, a really clear picture starts to emerge about what it actually means to build for resilience. This chart really lays it all out, doesn't it? The panel system just excels in all the areas you can actually control, like factory precision and speed. The stick-built method, on the other hand, is defined by things you can't control: on-site variability, long build times, and just more things that can go wrong. It's really a choice between a predictable process and a variable one. So here it is, the final scorecard. The differences are just stark, right? Across the board. Continuous panels versus individual studs. Non-combustible versus combustible. Building in weeks versus building in months. But honestly, that last line might be the most important one of all. Factory-based quality control versus labor-dependent results. It's the difference between knowing what you're going to get and just hoping for the best on site. And all of this leads to a really powerful conclusion from the source material. Familiarity does not equal resilience. Think about that. We build with wood frames because that's what we know, it's what we're used to seeing. But in a world with new and bigger challenges, just because something is familiar, that doesn't mean it's still the best way to do things. And that leaves us all with one last, pretty critical question to think about. As our weather gets more extreme, as energy gets more expensive, we really have to ask ourselves, is the way we've always built still the right way to build for the future that we are actually facing?